Hello everyone, this is Madhuri, working as an assistant professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology. Today I am going to discuss transformers as a part of DC machines course. Moving on to the very first slide of the transformers topic. Here are the list of contents which I am going to discuss it today. First one is the definition. What is the proper definition of the transformer? Second topic is nothing but the working principle of operation of a transformer. And next, the construction of the transformer. In detail, we'll be discussing about each and every part of the transformer. Next is the EMF equation of the transformer, and then comes the conclusion of this particular topic. So, transformers, it is a basic component or the essential component which we see in our day-to-day lives. So, it is one of the most essential electrical component in the modern day electrical systems. So in transformer, we find various wide range of applications. It is used near the generating stations, near the substations and the household applications, and also in the industrial applications. So without transformer, we can see that the operation of the power grids would be inefficient, and it would also be costly. Why? Because this costly term comes into the picture. Why? Because transformers work on the basic principle of stepping up and stepping down of the voltages. So this cost term is involved. If that stepping up and stepping down of voltages is not present in the power transmission system, it would be very difficult for the voltage applications of the loads, which has to be met according to the particular rating of the transformers. So which will result in the greater energy loss and higher operational expenses. So to minimize all these disadvantages in the power grids, that is efficient operation of the power grid, and to minimize the cost expenses involved in the power grid, and also to reduce the energy losses in the transmission system, and also to reduce the higher operational expenses, we use the power transformers. So the power transformers are mainly used to step up and step down the voltages without the changing in the supply frequency. So if you see at the constructional point of view, it is a static electrical device which does not have any rotating parts in it. So in which the transfer of electrical energy happens from one voltage level to another voltage level. So primarily, as I told, it is used to step up or step down the voltages while keeping the frequency constant, the supply frequency constant, which is nothing but the standard supply frequency of the Indian power supply is nothing but 50 Hz. So a transformer is used to change the voltage, AC voltage level. As the primary supply given to the transformer is the AC supply, so it is basically an alternating quantity device. So this change in AC voltage level from the primary circuit to the secondary circuit in detail will be discussed in the working principle of the transformer. Moving on to the working principle of transformer, the main principle behind the operation of a transformer is nothing but the Faraday's laws of electromagnetic induction. So we know already, we have discussed all the three cases of the Faraday's laws of electromagnetic induction in the very initial classes of DC machines course. So the rate of change of flux linkages in any current carrying conductor or any current carrying coil will induce an EMF, that is nothing but the electromagnetic force in that particular conductor itself. So this Faraday's laws of electromagnetic induction is again the basic working principle behind the transformer. So in transformer, if we see the structure of transformer, we can see there is a magnetic core. The material with which it is made up of will be discussed detailedly in the construction, and the material of the windings will also be discussed in the construction. For now, if we see the basic structure of a transformer, we see a magnetic core, which is nothing but given as a transformer core here in the figure, upon which on the primary side there is a primary winding, and on the secondary side there is a secondary winding. We basically connect the AC supply to the primary winding, which delivers the current to the entire transformer, and we basically connect the load to the secondary side of the transformer, So this current which travels from the primary circuit to the secondary circuit with the help of Faraday's laws of electromagnetic induction, and through this common path between the primary winding and secondary winding is detailedly discussed in the working principle of transformer. So basically, we first connect the AC supply to the primary circuit of the transformer. As soon as we connect the primary supply to the conducting material, that is nothing but the winding of the transformer, a current I1 starts flowing in the primary circuit of the transformer. So this current I1 will set up an alternating flux in the primary part of the circuit, which changes with respect to time. So this change in alternating flux with respect to time will cause an EMF E1 to be induced in the primary circuit of the transformer. So this EMF induced, which is induced in the primary winding, will link to the secondary winding through the common path that is nothing but magnetic core. So when this time varying flux and this induced EMF links to the secondary side or the secondary circuit of the transformer, there will be an EMF E2 which will be induced in the secondary winding, which drives a current called as I2 or IS, which is nothing but the secondary current, which is used to drive the loads which are connected to the secondary circuit of the transformer. So this is nothing but the basic working operation of the transformer. So the principle behind the working of the transformer is nothing but the Faraday's laws of electromagnetic induction. So here this law is basically seen in the primary winding. Here this winding is nothing but the current carrying conductor to which an alternating supply is given. So this alternating supply will set up an alternating flux in this magnetic core. So this magnetic core, as it is common for both the primary windings and the secondary windings, the flux will be flowing from the primary circuit to the secondary circuit in the magnetic core. So with this we can say that the electrical systems or the windings are electrically separated but magnetically they are coupled. So when we are using the term magnetically coupled, so nothing but these two windings are wound on the same magnetic core. So that's why we are using the term magnetically coupled but electrically separated. As they are electrically separated, there are separate induced EMFs in both the primary circuit and secondary circuit, and there are also different currents I1 and I2 in both primary and secondary part of the transformer. So that is the reason we say that the windings are electrically separated but magnetically coupled on a common magnetic core, which is nothing but called as transformer. So when the primary connect, as I told, when the primary winding is connected to the AC supply, current starts flowing through the primary winding, which can be seen in the previous circuit. So this primary current starts flowing in the primary circuit. So this winding, which is linked to the magnetic core, the current passes through this winding and the primary coil produces an alternating flux in the core. So as soon as the current starts flowing in the primary winding, there is an alternating flux which is set up in the primary circuit of the transformer. So this flux, as it is an alternating nature, so it is also linked to the secondary winding of the transformer. So here we can see mutually induced EMF, that is nothing but E2 in the secondary part of the transformer. So when the load is connected to this secondary part of the transformer, then a current starts flowing through that winding. So in this way, an energy is transferred from primary side of the transformer to the secondary side of the transformer with the help of Faraday's laws of electromagnetic induction principle. And also we can say that there is a mutual induction happening between the primary circuit and secondary circuit of the transformer. So in this entire operation, we see the main thing, the flux which is flowing through the common magnetic core links not only the secondary winding but also there is E1 and E2 are the respective induced EMFs in the primary and secondary parts of the transformer. So apart from this, there will be a self-induced EMF because of the currents which are flowing in the respective windings individually. So those EMFs are nothing but called as self-induced EMFs. This self-induced EMFs will oppose the mutually induced EMFs based upon the laws of Lenz's law. So Lenz's law basically states that effect opposes the cause. So the cause for this is nothing but the flux, and the effect is nothing but the self-induced EMF. So self-induced EMF will oppose the flux. So that's why, based upon this Lenz's law, there is a flux. The self-induced EMF in the primary and secondary circuit of the transformer is called as back EMF. So this back EMF will always oppose the mutually induced EMFs E1 and E2. So this is about the working principle of the transformer. Moving on to the next slide, we see the constructional features of the transformer and what are the various parts in the transformer and what are the respective functions we are going to detailedly discuss under the construction of transformer. As I told, the transformer is a static electric device, so it doesn't have any rotating parts. So it does not have any frictional losses or rotating losses or the frictional or windage losses. So it is a static device. It does not have any rotating parts. So transfer of energy happens from primary circuit to the secondary circuit of the transformer with the help of electromagnetic induction, which we have seen clearly in the working of transformer. So basic parts of the transformer are nothing but the laminated core, the windings and the insulating materials, the transformer oil, the conservator tank and the Bucos relay, the breather, the cooling tubes and the explosion vent. So all these parts will be discussing clearly in the coming slides. So the first and foremost constructional feature of the transformer is nothing but the laminated core. So name itself indicates that the core is laminated. The reason for lamination is nothing but to reduce the iron or core losses. So if you see the structure of this transformer, there will be thin laminations like this in the core of the transformer, which will be again insulated from each other by using the insulating agents. So these laminations are used to reduce the iron or core losses. Different kinds of losses will be detailedly discussed under the topic of losses in a transformer. For now, the purpose of lamination in the magnetic core in a transformer is nothing but to reduce the iron or core losses. So reducing the losses in the transformer will indirectly, it is related to increasing the efficiency of the electrical device, that is nothing but the transformer. So the main reason for laminating the core is to reduce the iron and core losses. So the basic function of this laminated core is it serves basically two purposes. So one purpose is to provide the mechanical support to the transformer, and also the other function is to provide the path for the flow of magnetic flux. So as we have seen that the two windings, the primary winding and the secondary winding are wound on the magnetic core. So it has to provide a path for the flow of flux between the two circuits, that is the primary circuit and the secondary circuit. Coming to the material with which the core is made up of is nothing but we basically use the soft iron or silicon steel for the laminations in order to provide low reluctance. So reluctance is nothing but the opposition offered to the flow of flux. A similar term to the resistance in the electrical terms. So in the magnetic systems, we come across reluctance. Reluctance is nothing but the opposition offered to the flux. So this magnetic core should have the reluctance to a very low value, so that there is a smooth flow of magnetic flux in this magnetic core. So the steel or the material which is used for the laminations or the construction of the magnetic core is of high silicon content, and it has to be treated with heat to have the better permeability and the low hysteresis losses. So basically in core we see two kinds of losses. One is hysteresis loss and the other is eddy current loss. So these two losses combinedly together called as core losses. So if we use high grade of silicon steel material to laminate our core, so this kind of losses can be reduced to a very high extent. So the laminations, the thickness of the laminations, first initially it is 0.35 mm to 60 Hz supply frequency, and it is 0.5 mm for 50 Hz of supply frequency. So again, these laminations has to be insulated from each other to avoid the leakage currents or the leakage of the flux. So that's why they are insulated from each other by a coat of varnish or an oxide layer. So insulation is provided in between the lamination layers, so with a coat of a varnish or an oxide layers, and we can also see the thickness of each laminations as 0.35 mm for 60 Hz of supply frequency and 0.5 mm as 50 Hz of supply frequency. So 0.35 mm is basically seen in the abroad countries. So Indian supply standard frequency is nothing but the 50 Hz of supply frequency. So this is about the core of the transformer. It basically serves two purposes. One is to provide the mechanical support and the other is to provide the flow of magnetic flux. It is made up of soft iron or silicon steel, and they are laminated to reduce the losses due to hysteresis and eddy current losses. And these are the thickness of the respective laminations, and these laminations are insulated from each other by a coat of varnish or an oxide layer. So we can see the different parts of the transformer in the figure here. We can see a main tank, bushings. We can also see a thermometer, an oil gauge, an explosion vent, conservator tank, the breather, Bucco's relay, radiators, the transformer oil, transformer core and winding are housed in the main tank. So they are situated inside the main tank. So next, coming to the windings of the transformer. These are nothing but the set of copper wires. We usually use copper for two reasons. It is nothing but first and foremost reason is nothing but the high conductivity of copper, and the next, this minimizes the losses in the transformer. If the conductivity increases, the resistance to the current flow decreases. So that is why we choose copper as the winding material in the transformer. So next reason is high ductility. So ductility is the process of making the material into thin wires or reducing the material into thin wires. It can be drawn into thin wires to make the windings of the transformer. So compared to all other metals present, copper has high ductility. So these are the two reasons why we use the copper as the winding material in the transformer. As we know that the primary winding, there are basically two kinds of windings, primary winding and secondary winding. Primary winding connected to the supply of the transformer, AC supply, and secondary winding connected to the load, or from which the terminal output voltage is drawn, from which the output is taken. And these primary and secondary windings are insulated from each other by using the insulation coating agents. So what are those insulation coating agents will be seen in the next slide. So basically windings are made up of copper. We basically have two windings. One is the primary winding and the other is the secondary winding. So why particularly copper is nothing but due to its high conductivity property and the high ductility property. Next, coming to the insulation agents. As we have seen, we need insulation between the core material and the windings in the main tank, and we also need insulation agents in between the laminations of the magnetic core. So all these agents come under the insulation agents. So insulation is necessary for the transformer. First, basically to separate the windings from shorting the circuit and thus facilitating the mutual induction process. So for the mutual induction to happen between the primary and secondary circuit of the transformer, we basically need insulation agents, and also to avoid the short circuit between the primary and the secondary circuit of the transformer, as they are electrically separated but magnetically coupled on the same magnetic core. So that is why we need these insulation agents. So insulation agents will have influence in the durability and stability of the device. Obviously, if we properly insulate the device or the windings in the transformer, the durability and the stability of the transformer will increase. So that's why these insulation agents have influence on the durability and stability of your transformer. So there are basically 4 types of insulating agents which we use in the transformers. Primarily used insulating agent is nothing but oil. So we also use, apart from this insulating oil, we also use insulating tape, insulating paper, and the wooden based insulations also, based upon the different ratings of the transformer. But for the higher rating of transformer, we basically use insulating oil as our insulation agent. Moving to the next part, that is nothing but transformer tank. We can see the transformer tank as a main tank, which is mentioned in this figure. In this main tank, it is an airtight tank in which there is transformer oil, there is also transformer core. Upon the core, the 2 windings are wounded. So all these are housed inside the main tank, which is nothing but called as transformer tank, and it is airtight container. So we can see the transformer core and the windings arrangement are immersed in the tank containing insulating oil. So the transformer gives the protection to the core and windings. So the main purpose of this transformer tank is to give the protection to the core and windings of the transformer. There are also cooling tubes which are welded to this main tank to reduce the heat which is generated due to the copper losses in both the primary and secondary windings of the transformer. So in the transformer tank, we see the core and the winding arrangement is immersed in the transformer oil, and also we have cooling tubes to the transformer tank to reduce the heat which is generated by copper losses in both the primary and secondary winding of the transformer. Apart from transformer tank, we also have a conservator tank. So name itself indicates that oil conservator tank. It is nothing but airtight tank in which we have transformer oil. So transformer oil is basically used for providing the insulation or for the cooling purpose of your windings. So this level of transformer oil in the main tank will be monitored, or the level will be maintained by this conservator tank. So basically, conservator tank is nothing but it acts as a reservoir or a reserve store for the transformer oil. Whenever the oil level decreases or increases in the transformer tank, so this conservator tank takes up the excess or deficient oil in the main tank, and it maintains a proper level of oil in the main tank. So this is nothing but it acts as a reservoir for the transformer oil. So in transformer, basically the increase in temperature occurs whenever the current flows continuously in the primary and secondary windings. So when there is increase in temperature, we see the oil expands. And when there is decrease in temperature, or when the load decreases on the transformer, we find the contraction of the oil. So all these contractions and expansions which happen in the conservator tank are taken up by this transformer oil present in the conservator tank. So basically the main function is to provide the space for the expansion and contraction of the oil in the transformer unit. So this conservator tank basically provides a space for the contraction and expansion of the transformer oil, and it ensures that the transformer tank is completely filled with oil at all the conditions. So it acts as a reserve to maintain the proper level of transformer oil in the main tank. Moving on to the next part, breather. So breather is similar to the respiratory system in the human body. So there is a breather in the transformer which is similar to this figure shown in the picture. So in this breather, we have silica gel, which is in blue color. The function of this silica gel is to absorb the moisture from the external environmental conditions. So this silica gel, upon the absorption of the moisture from the external environmental condition, it is initially blue in color. It turns out to be pink when it absorbs moisture from the external environment. So this silica gel, which when turned to pink, has to be replaced with a new silica gel, which is again in blue color. So what happens in breather? So when there is change in temperature inside the tank, we know that the oil expands or contracts according to the change in temperature inside the oil. So when the transformer, assume that when the temperature goes down, it will make the oil to contract. So the atmospheric air gets absorbed inside the transformer. So this process is nothing but in the contraction, the atmosphere air gets inside to the transformer. Upon the expansion, the air is expelled out of the transformer. So which is nothing but very much similar to the breathing in the human beings. So that is why it is called as a breather. So contractions and expansions are monitored by the breather, and this transformer oil will be, this breather avoids the exposure of the transformer oil to the external moisture with the help of the silica gel present in its body. So breather consists of silica gel, which prevents the atmospheric moisture from entering into the tank from outside. So all the moisture gets absorbed by the silica gel and it turns into pink color. Part of the transformer is nothing but the cooling tubes. So cooling tubes we basically see in the construction part of the transformer. So all these are nothing but the cooling tubes or the radiators. The term radiators is nothing but all the cooling tubes which has a fan with it. So this external cooling for the transformer is required because when the load on the transformer increases, there is increase in temperatures in both the primary and secondary windings of the transformer. So in order to cool this entire transformer, we need radiators, which comes with a fan which is situated on the main tank. So the heat produced in the winding and the core due to copper losses in the conductors or the hysteresis and eddy current losses in the transformer core. So this heat has to be dissipated properly for the efficient operation of the transformer. So cooling tubes remove the heat from the transformer, oil and the tank. Through these cooling tubes, the coolants may be in the form of oil or air which is passed into the transformer. So there are two types of cooling techniques again. We have natural cooling and the forced cooling. Natural cooling is from the air from the external environment, and the forced cooling is nothing but with the help of oil or the external fans which are situated in the form of radiators on the main tank. So this cooling capacity will again depend on the size of the transformer or the rating of the transformer. And the Bucco's relay. So Bucco's relay is nothing but, in electrical terms, relay is nothing but a protecting electrical equipment which disconnects from the main circuit from the load circuit. So this in transformer we see a Bucco's relay. So Bucco's relay is basically a gas actuated relay in transformer. So it is a safety mechanism in the transformer which is a gas, or according to the rating of the transformer, it can be gas actuated relay or a oil actuated relay. So designed to detect basically the internal faults by monitoring the gas and oil movements in the transformer. So by monitoring the gas and oil movements in the transformer, this Bucco's relay will disconnect the transformer from the external load circuit in order protecting the loads and the transformer. So it is used to detect the faults in the main tank of the transformer. These can be internal faults and external faults. So these faults can be interturn. The turn faults, that is basically which occur in the windings of the transformer, or the insulation breakdowns in the magnetic core or the windings of the transformer, or it can be short circuits or earth faults or overheating of the transformer or oil leakage of the transformer. All these kinds of faults are sensed by this Bucco's relay. It sends an alarming signal to the main supply system and it gives an alarm and disconnects the load from the main supply system. So in turn protecting the transformer and the loads connected to the transformer. So this Bucco's relay acts as a protecting equipment for the protection of the transformer. It interrupts the transformer's input supply so that the great damages may be prevented, and it also serves the purpose of fault diagnosis. So all these kinds of faults are sensed by this relay, and it gives an alarming signal disconnecting the transformer from the supply system and the load system. And the final thing is nothing but the explosion vent. If the pressure inside the transformer increases in any case, so the damage, to avoid the damage to the transformer, we have an explosion vent which, when upon opened, this internal pressure which is at high amounts will be released to this explosion vent, in turn protecting the transformer from the main damage. So excessive pressure in the transformer is released through the explosion vent. So this is about the construction of the transformer. So basically we have discussed today about what is a transformer, what is the working principle of transformer, and what is the construction of a transformer, and what are the different parts under the construction of transformer. Thank you.